Welcome back inside the John R. Kirk Planetarium here at SUNY New Paltz. My name is Raj Pandya. I'm the director of the planetarium. And as you can see right now, we can't have anyone inside of the planetarium as we do our part to socially distance to stop the spread. And so unfortunately we can't have our regularly programmed astronomy night shows, but I thought I'd make this short video to show you what the sky looks like in the month of May 2020. So keep looking up. If you were on the campus of SUNY New Paltz and you looked straight up, this is what you would see.
Even if you are not in New Paltz right now, the sky projected in this video represents what you would see pretty much anywhere in New York State.
Now, this looks a little bit different from what you're usually seeing in the planetarium because this landscape would be pasted all around you. So you would see more of a realistic view. Right now, it's as if you are lying down on top of the roof of the Kuykendall Science Building and looking straight up. But we can change that. For example, let's say you stood up and you looked west on the campus of SUNY New Paltz. What you would see is something like this. So I'm going to point you west. There's a W for west here, and we can see the ridge in the background and parts of campus. If we pivoted and looked north, we would see this part of campus. There's JFT in the distance. And if we looked east, this is what we would see. We're standing again on top of Kuykendall Science Building, so that's part of the science building. If you're looking south, this is what you would see. You can see the trees and the walkway. And if we actually look down, you can see that is the top of the planetarium dome sticking out of the roof of the building. So I'm going to show you different views, and right now, again, we're just looking west. So what we are viewing here is the middle of the day in the month of May 2020. First of all, we can see, of course, the sun is shining because it's daytime. You can find the time at the bottom of your screen here and the date. So this is for the middle of May. As I start time moving forward now, you can see the sun is going to make its way down towards the northwest and actually set above the northwestern horizon. We are in springtime now, so the days are getting longer and the sun sets in the northwest. And right about here, it's dusk. And so we can take a look at SUNY New Paltz campus as night is approaching, kind of just swing all around and see our beautiful campus. Now you can see a dot has already appeared in the sky, and that dot's something we've been seeing all year in 2020, just above where the sun set, right over here. This is the planet Venus. So Venus is still there, shining bright, and it's going to eventually fade out as we move towards the summertime, but we can still see it now signaling the start of night. Now let's keep looking in the west and see what stars will appear as it gets darker. So I'm fast forwarding through time once again, and you'll see the sky is going to change color and some stars are going to appear. Of course, I've removed all clouds and things like that from the atmosphere, and also we're going to remove all light pollution soon so we can see an ideal view of the night sky. I'm going to point you straight up again. Just imagine you're lying on your back and you would see these stars and constellations. And we're going to fast forward to 9:30 p.m. Okay, right about here. I'm going to remove the atmosphere so we can actually see the stars without any distraction. So the first few constellations I'm going to point out that we can see in May are guided by probably the most famous constellation, which you can see kind of in the middle of the sky right now. Probably the most famous constellation in the northern hemisphere, which is, of course, the Big Dipper or Ursa Major. And so you can find 7 bright stars right here in this pattern. And this is what we call the Big Dipper.
And the full constellation includes other stars that you can connect here, and we get this shape we call Ursa Major. We can highlight that for you. And instead of talking so much about the Big Dipper today, I'm going to use it as a guide to find some other constellations. So if we were to look southwest right now, I'm going to change the camera angle. This is our southwestern horizon, as you can see here. We could use part of the Big Dipper to find the first constellation for this evening. So you take these last two stars, which are kind of in the pot of the Big Dipper right here, and if you point them down towards the horizon, towards the southwest, you'll get to this hook shape. So you have this hook right here with a bright star here called Regulus, and then it makes a line towards a right triangle. And so this is the next constellation that we will focus on. This one is called Leo, the lion. And Leo is a really iconic constellation of the springtime. It's something that definitely pops into view easily. And you can see it sort of looking like a lion, according to the ancient Greek mythology. We have Leo here with his head going this way, his body here, and then back legs and tail. So this one kind of does look like what it's supposed to represent. Now, along with Leo, we have a small constellation right above it called Leo Minor. And so the way you find that is look for the space in between the constellation of Leo here and the Big Dipper, which we showed before. And we get this tiny little group of stars here, this small triangle. So this small triangle is what we call Leo Minor. So it's basically the little lion. So you've got your big lion, Leo, and then your cub lion right here. So for you Lion King fans, it's like Simba and Mustafa, and you can remember all those stories that go along with those. Now, keeping in this part of the sky, we're going to focus on a deep sky object. So deep sky object is something you can't see displayed right now. It's something that you actually need a telescope to view. So we're going to look at something called the Beehive Cluster, which is a group of stars packed together, a star cluster. And to find the Beehive Cluster, we're going to use this head of Leo right here. So Leo's head, again, it says backwards question mark. And if you hook this backwards question mark into this area here, into this area called Cancer, deep inside of Cancer, there is the star cluster. Now we can't see it too well right now, so I'm going to put on a bunch of little hints that help us. And we can click right here. The Beehive Cluster, also known as M44. So this is an open cluster of stars. There are two major types of star clusters, open clusters and globular clusters. We'll take a look at both today. And right now we're going to zoom in on the Beehive Cluster. So we take a close-up look. If we had a really good telescope, we could see something like this. So you see lots and lots of stars in here. So I'll give you a little bit of the background for the Beehive Cluster. It's at a distance of 577 light years from Earth. There's about 1,000 members in this cluster. So about 1,000 stars all gravitationally bound together. And when stars are in a cluster like this, this means they all form together out of the same original material at about the same time. And so we can estimate the age of this cluster. Since all of the stars are about the same age, we can use different observational techniques, and we can get a good clue as to how old these stars are. And so this being an open cluster means the stars are pretty young. So they're about 600 to 700 million years old. That's very young for stars, 600 to 700 million years old. And we're going to come back from that and view the sky, again looking west-southwest. I'll put us back into our view of the sky just lying down. Now we're going to focus on the eastern part of the sky, and we're going to find a constellation called Corona Borealis. And so once again, our Big Dipper is a nice guide here. So here's the Big Dipper. This time we're going to take the handle of the Dipper, and we're going to follow it to an arc and get to a bright star nearby the constellation we want. So we follow it to this star called Arcturus. So the key here is you arc to Arcturus, but then we're not going to stop there. We're going to bounce back up to this constellation, which looks like a C shape. And so I'm going to point us now towards the eastern part of the sky, where we will see this. So here we are looking east, and the next constellation comes up here, Corona Borealis, which means the northern crown. So Corona means crown, and Borealis means of the north. So this constellation also kind of works. It could be any kind of circular thing, but the Greeks decided to call it the northern crown. So that works pretty well. You can see a crown there. So try to find this constellation looking east. And again, the time is about 9:37 p.m. as long as you have a clear, dark sky. Now we're going to look at another deep sky object. So this one is called the Cat's Eye Nebula, and it is a planetary nebula. It's going to be in the northeastern part of the sky, and you definitely won't see this with your naked eye, so we will zoom in. First we'll center and slowly creep onto this object. And we can see this beautiful image of a planetary nebula. So a nebula is a cloud of gas and dust, and there are definitely different types of nebulae. A planetary nebula is what you're seeing here, and planetary is actually a really bad name. It doesn't really have anything to do with a planet. What this is the death of a low-mass star like the sun. When stars go through their life cycles, at the end of their lives, they do different things depending on their mass, and this is what the sun is going to do at the end of its life cycle. It's going to expand, and what you're seeing here, the gas here, are the layers of the star's outer atmosphere that are being ejected into space. They're being pushed away from the central core of the once living star. Now, this is not a violent thing. This is not the same thing as a supernova, where you have a very violent, quick explosion. This is a very slow death. It's just a release of the outer layers of the star's atmosphere into space. And so this object shows us a preview of what our sun is going to do. It's located 3,300 light years away from the Earth, and it's shedding mass at a rate of about 20 trillion tons per second. 20 trillion tons of hydrogen are being expelled off of the central dying core of the star, which is called a white dwarf. And so that's a lot, 20 trillion tons per second. But at this rate, the nebula can last probably another 10,000 years or so before this gas just dissipates into the interstellar medium and we can't see it anymore. So we're going to zoom back out to our normal view of the sky. And I'm going to make it later now. So I'm going to rotate the Earth, and you can see the whole sky moving above you. And we're going to take it to 10:30 p.m. So here we are at about 10:30, and I want to focus on a nice constellation. It's actually the biggest constellation in the sky in terms of the amount of area it takes up. So in order to see this one, we're going to look southwest. So I'll reposition our camera now. And you'll find a familiar shape. The one we started with is Leo, it's still here. Leo's still in the sky. And now we're going to use Leo to find the largest constellation. So once again, we can use the head, this part of Leo. This is the hook shape. And previously we found the Beehive Cluster, which is kind of over here. This time we're going to hook straight down to find the head of this constellation called Hydra. So find the hook, point down towards the horizon, and you can see the head here, a group of stars, and then it kind of zigzags down and it goes all the way across the sky. I'll highlight that for you. This is Hydra, the largest constellation in the sky. And in the Greek mythology, you may know that Hydra is a water snake. Now, it might not look so big here, but I'm going to show you the boundaries of this constellation. And it's really big, and I'm going to focus us back to seeing our all view of the sky and get rid of the landscape. So we can get rid of the buildings at SUNY New Paltz just to see how big this constellation is. It takes up this entire portion of the sky. Really, really big. Now in the Greek mythology, Hydra actually had 9 heads, but here, of course, it's just showing the one. Probably not enough stars to make 9 heads out of over here. Now, if we follow Hydra's winding tail down here, we can get to two more really bright constellations. So now we're looking south. So I'll turn the camera a little bit more towards the south. You can find a bright box, this group of stars right here, which is called Corvis. Now, the Greeks could have made this constellation anything they wanted, but they made it a little raven. So there's Corvis. It's actually a very bright constellation, easy to see in the real sky. A little bit more of a challenge is the constellation right next door to Corvis. It's a little bit fainter. So if we go down here, we have a group of stars which makes up the base of this constellation here, and then the upper part, which is the cup. And so this constellation is called Crater. And crater means cup, or you can think of chalice. So there is your cup. Sort of like, looks like the Stanley Cup, which would normally be happening around this time of year. Of course, it's not this year, but that's how I always remember that one. And now we'll take a look back at our main view of the sky. Time for some more deep sky objects, so things that we need a telescope to see. We've already looked at two of these. And now we'll look at slightly different kinds of objects. The next thing we're going to look at is called M3. You'll notice there's a lot of M's up here in the sky, and those M's are denoting that it was cataloged by Charles Messier, famous French astronomer from the 1700s. So we're going to look at M3, right up at the top of the sky. This would be about zenith, so that means right at the top of the sky. If you're lying down on your back, this is where you would look. And this is a different type of star cluster. This is a globular cluster. So there's many more stars in here. So we zoom in and we see this incredibly dense, packed group of stars. This one is really impressive. It's one of the largest star clusters in the Milky Way galaxy. And it's pretty far away. The distance to this cluster is 34,000 light years, means that the light from these stars left 34,000 years ago. And we're just seeing that light now, based on the extreme distance. There's about 500,000 members in this cluster. 500,000 stars in just this one glob, which is really impressive. Makes it one of the biggest. The radius of this cluster is about 90 light years. So we're talking about a pretty large object. Traveling at the speed of light to go from the center towards the edge would take 90 years. And again, because it's a star cluster, all of the members have about the same age. And so we can estimate the age of this cluster at 11.39 billion years old. 11.39 billion years old. That makes it really, really old. It's one of the relics of the Milky Way galaxy. That's almost as old as the universe as we know it. The universe itself has an age of about 13.8 billion years old. And so this group of stars is almost that old. So it must have been part of one of the earliest building blocks of our galaxy. We will zoom out now. And speaking of galaxies, we'll look at a different galaxy. Remember that we live inside the Milky Way. That's our home galaxy. But all these little red things you see here that are ellipses are other galaxies. We'll visit the galaxy M106. So we're increasing how far we're looking at each object that we went through tonight. So this is going to be the furthest thing that we look at tonight. And we'll zoom in and we'll see this beautiful view of an edge-on spiral galaxy, M106. The distance is 24 million light years. So really far away now, millions of light years. You can see the spiral structure. It's got some arms emanating from the center. There's also clouds of gas and dust in here, which are typical of a spiral galaxy. And this one is special because it has what we call an active nucleus. So if I zoom in a little bit more, the middle, the nucleus is extremely bright. And when galaxies have an active bright nucleus like this, it means there's something in there which is generating lots and lots of light in all different parts of the electromagnetic spectrum. And as is always the case, that light is generated by the accretion disk around a supermassive black hole. So galaxies at their centers have supermassive black holes. And based on the amount of light that's coming out of this central region, astronomers can estimate that the mass of the supermassive black hole is 39 million times the mass of the sun. So this is a really, really powerful, massive object. Even though a black hole itself is incredibly small, the light is coming from the disk of gas and dust orbiting around that black hole. And because the black hole has so much mass, it has such a strong gravitational influence on the accretion disk around it. So we'll zoom out once again and return to our home view. Again, here we are at SUNY New Paltz. And at this point, I'm going to make it much later. As the Earth spins, the sky appears to rotate above us. We'll go past midnight now. And this is what we'll see later on in the summer. We'll see our own galaxy, the Milky Way, starting to stretch across. So this is the edge of our own Milky Way galaxy that you see coming into view here. We'll focus on that later in the summer when it becomes visible at an earlier time. Right now, as you can tell, it's 3 a.m. So it's getting pretty early. It's getting so late that it's early. And I'm going to turn the atmosphere back on. And let's refocus on the eastern part of the sky. And as nighttime slips away, we'll see the glow of dawn. And of course, now we'll have sunrise. So the sun is going to rise north of east. North of east. There's our sun coming up. And now it's morning at SUNY New Paltz once again. We can look all around. And there we are. So we've done pretty much one full rotation of the Earth to see what the sky looks like. In this view, you'll see the moon is visible, but it depends exactly on what day you're viewing it. If you are viewing on May 16th, you'll see this. But the objects that I showed in this video are applicable for pretty much any time during the month of May. So thanks for watching. I hope you enjoyed it. Stay tuned for more videos on the sky. Keep looking up, everyone.